Then for visible light, you may want to add in, your tint, right? Your iron oxide tints, because your typical broad spectrum sunscreens may not protect against visible light, right? Because those filters are not covering those wavelengths of light.
Welcome to the Learn Skin podcast with me, Dr. Raja.
And me, Dr. Hadar, where we discuss all things skin.
Join us as we delve into the art and science of skin health in today's episode.
Hey, Raja, can you say the thing I told you to tell them?
Of course. We are board-certified dermatologists. This podcast is meant for educational and informational purposes only and is not considered medical advice, nor does it serve as a substitute for professional care by a doctor or other qualified medical professional. All opinions shared do not express the views of Learn Health, Inc. Let's get to the good stuff.
Hey, Raja, how are you today? Oh, Raja, where did you go? Folks, I'm alone again. But don't fear, we have a mystery guest that will help us today. And today we wanted to talk to you about the sun. And not just the sun, but the radiation from the sun that hits our skin and causes so many different issues. And we've been doing the same routine over and over with sun protection, but perhaps there are some new avenues we need to explore because we're getting forever exposed to the sun and the damages are real and we need some help here. So we thought we'll invite an expert, and I really can't think of a better person to talk to us about science and how we can really work science in our benefit, better than our guest, and that is Dr. Naiem Issa, who is with us visiting for this episode. Dr. Issa is a board-certified dermatologist, and he is currently the director of clinical research and academics with Forefront Dermatology, which is a huge group practicing all over the U.S., so a big job, but he is practicing in his little corner at Vienna, Virginia. So, Naiem, welcome to the podcast.
Thank you, Hadar. It's a pleasure to be here. Thank you so much.
Fantastic. And so, I think with a lot of our guests, what we really like is to kind of get your angle on what made you so interested in this topic. Because, we mentioned you're a dermatologist, you also have a PhD, you have a vast background in research and skin science in general. What is so interesting about sun protection to you?
So, for me in general, I like to be able to distill problems in medicine into, let's say, programmable modules. And I got interested in sun protection because I thought we could look at sun protection and sun damage almost like an algorithm with different tunable parameters. So basically making it mathematical almost. And so what I was able to do is kind of distill sun protection into different flavors, such as using filters against ultraviolet light. And then what do we do with visible light? And what about antioxidants and repair enzymes? How do these fit together? And can we tune each one and kind of put them all together to have the ultimate in sun protection?
Yeah, I really like that, Naeem, because a lot of folks think that, I'll just put this product on my skin and I'm done, I'm protected. But in reality, the damage that we get from the sun is more complex. I mean, for example, you can have some genetic tendencies. We even know of some rare diseases that will make you more sensitive to the sun, etc. So maybe I like this idea because it kind of puts through the concept that protecting from the sun is as a multi-pronged effort. So maybe you can put this all in kind of nice, neat concept for us. How does that go in your head when you think about all the aspects and variables in this equation, if you will, that you described? Can you list for us those variables first? What goes into that equation?
Sure. So first and foremost, I think that we have to look at what light is. Back to our physics 101 class from back in the day,
Love
right?
it.
Right. So we start off with the infamous electromagnetic spectrum. All right. What the heck is that and why do we even care? Well, light is composed of different wavelengths of light, right? You have your ultraviolet spectrum, you have your visible light spectrum, which I call the rainbow or Roy G. Biv. And then you have your infrared spectrum, right? And then you have different penetrations of the different regions of light from the electromagnetic spectrum. And that can have different physiologic effects on different parts of the skin, depending on what they're hitting and where they're hitting, right? So, for example, we all talk about ultraviolet light. You have ultraviolet A and ultraviolet B. as well as ultraviolet C, but we don't talk so much about that because of the ozone layer, right? But for simplicity's sake, let's go with UVA and UVB. Now, we have different penetration distances, such as the epidermis and the dermis. And in these areas, you can cause, first and foremost, photoaging, right? You can start getting wrinkles, you can have the destruction of collagen, so on and so forth, right? So that's your classic photoaging. But then furthermore, you can get dermatoses. So you have these photodermatoses. So you can get, let's say, flares of, lupus for your autoimmune patients. You can get PMLE for some of these patients. You can also have alterations of the immune cells in those areas that can lead to, let's say, phototoxicity and so on and so forth. So ultraviolet light, and most importantly, of course, is skin cancer. Right? I didn't touch on that main aspect just yet, but here
I think
you're
that's important.
of course. I mean, I'm leading you, down a path here. So of course, skin cancer protection is our ultimate, but don't forget these other dermatoses and photoaging. But when it comes to ultraviolet light, you have direct effect of the ultraviolet light onto the DNA, right? And you make these thymine dimers, right? And thymine dimers cause errors in DNA replication, and then these DNA replication errors will lead to mutations that can lead to overgrowth and keratinocyte carcinomas and melanocyte carcinomas and so on and so forth, right? So it's just an additive effect there for these mutations from ultraviolet light. Now, as we move from ultraviolet light, I mentioned visible light. Visible light's also important in its own right. Not only can it cause photoaging, but there's a significant impact on hyperpigmentation and melasma, right? So visible light is very important, and we have to protect from that range of wavelength of light in order to have protection from, let's say, pigmentation changes, right? And then infrared light, we're still kind of figuring out, is it good or is it bad or what have you? We know we have some of these devices out there as well that incorporate infrared light, for biorejuvenation, what have you, but still the jury's not out yet on the utility of infrared light. So that's kind of where I sit from a 1,000-foot view when looking at the electromagnetic spectrum as it comes to physiology of the skin and the damage that could be done.
Well, that was a wonderful overview. And, I think it is important to also keep in mind we talk about this in sort of a negative kind of view of sunlight, and there are some benefits to sunlight,
Mhm.
and we know that we need that for vitamin D. We know that we need that to be happy. We know that there is some anti-inflammatory effect. So it's all probably a matter of dose, right?
Mhm.
What is your take about this idea of dose? How much sun is enough? Is too much? Is too little? What do you tell patients? I mean, we're not
Mhm.
making any medical recommendation, just kind of for people to get a sense of what are we talking about in terms of where there's too much.
Absolutely. And so I first off start off by saying that humans, uh, were existing with the sun first and foremost, right? And there is variations during the day with for the sun. That's why we have the sun and the moon. And ultimately, we have to have some sun in order to exist properly, right? That's how the physiology just is. That's why we also have diurnal variations and so on. But ultimately, to answer your question, Hadar, is that I recommend folks, first of all, they should be using this sunscreen in a broad spectrum to cover UVA and UVB and what have you, the typical recommendations. But to be able to get at least 15 to 20 minutes of natural sunlight every day because of that anti-inflammatory effect. And specifically, we do know that in the ultraviolet B range that you can have an effect on your T cells and your regulatory T cells and so on and so forth, which is great. But the natural sunlight and in the presence of your sunscreen, by the way, it's still enough to have an anti-inflammatory effect and also to generate the proper amount of vitamin D conversion from your skin. And we have studies that actually prove that, especially in the Blue Journal, in the Journal of American Academy of Dermatology. We do have that data that proves that along with your sunscreen, you can still get 15 minutes of sunlight and be able to produce the right amount.
Yeah, excellent. So we don't want people to be completely afraid of the sun. You just have to do it in the right way, in the
Mhm.
responsible way, right? We are arguing for being responsible with your health, and
Mhm.
understanding that what you can do can have some damage, but it doesn't mean you have to now go and hide in a cave. All right, so let's look into that damage, because how we you gave us a good sense of, okay, this is the biology of things,
Mhm.
and the physics of things, we should say. What happens when things go wrong, when we get DNA damage? How does that work? And more importantly, what is available now for us to protect from these bad effects of the sun?
Certainly. So let's trace the line of damage, right? So to conceptualize, so you have light hitting the skin, right? At various levels. So the first thing that happens is that this light can cause a pro-oxidative damage, right? Where you are hitting the lipid membranes and other enzymes and what have you, and you're making these reactive oxygen species. And reactive oxygen species, as you can imagine, are quite reactive and they can cause further damage to the cell at different aspects. So that pro-oxidant state, as we know, is bad, right? So that's one aspect of the damage tree. But in addition, right, as we mentioned before, we have the mutational damage in the thymine, specifically in your DNA. And when you get these dimers, you then try to bring the DNA repair enzymes, right, to come in as kind of like a cut and repair kind of system, right? So the DNA repair enzymes come, they try to find these thymine dimers, cut them out, and then bridge back together the remaining parts of the DNA so that it can try to act normal again. So these are the two major pathways of damage, right? So going back to my concept of, you have the rays, the sun rays themselves, right? That's one module. Then you have the pro-oxidant module, okay, in of itself. Then you have the DNA repair module, right? So I have three modules in the way I kind of look at that. So for the first module, looking at the rays themselves, you can block the rays, right? That's where your sun protection comes in, right? You have your physical barriers such as your zinc, right, and your titanium oxide and what have you, right? And you can also have your chemical sunscreen such as oxybenzone and what have you. So that's one aspect. Then for visible light, you may want to add in, your tint, right? Your iron oxide tints, because your typical broad spectrum sunscreens may not protect against visible light, right? Because those filters are not covering those wavelengths of light. So that's one aspect, right? Then you can have antioxidants put into the mix, right? And so you can have sun protection that also contains antioxidants in their formulations, or you may want to add some oral antioxidants, right? Such as, you may have heard of polypodium leukotomas, right? Also, affectionately known as heliocare, and so on and so forth, to try to blunt that response. And then last but not
Love that
least,
stuff. Yes.
right? Isn't it amazing, right? It's really good stuff. And I highly recommend for everybody for this reason. And then to end
Yeah,
the
and
trifecta.
it has a very robust body of evidence, actually. So it's really nice to have some of these things on the market. Yes, go ahead.
Of course, and just to wrap up the trifecta, right, is that for the DNA repair enzymes, there are some, over-the-counter products that are oral as well as topical that do incorporate actual enzymes, right, that can be coming from mammals as well as algae or microbiota, that these are full-blown proteins that in the presence of light, they get turned on and then they go and repair the enzyme. So you're supplementing that. So this is what I call the trifecta.
Love it. Okay, so before we go and talk about some of these new technologies, what are a couple of oral supplements that you like to use in the clinic? We mentioned the polypodium leukotomas. What about
Mhm.
nicotinamide? Do you use that?
I do like nicotinamide. Now, so majority of my patients can tolerate nicotinamide, and there's a robust amount of evidence, especially way back, and in Hadar, I remember when I was learning under you, even a couple of years back, we even looked at the New England Journal paper that looked at the evidence of nicotinamide, in randomized trials, looking at the protection against actinic keratoses, right? Does that ring a bell to you at all?
Sounds familiar. I even remember some bets involved, but we're going to keep it at the University of Miami. Okay, go
Yeah,
ahead.
right.
Yes.
So essentially, nicotinamide is a great adjunct, right? And I love to use that. There is evidence for that, but sometimes we have to counsel our patients about potential flushing. But rarely do I see flushing in my patients, but it is there for some. So I like to incorporate that. And another big one I like is turmeric. I'm a big fan of turmeric.
Yes, and we definitely like to use those supplements, and folks can even introduce this. It's simple, it's over the counter, and now
Mhm.
we even have products that combine these. And you can go on the market and shop around and be obviously be a smart consumer. But there are product supplements that contain some of these elements we just mentioned, but also can maybe combine with something else that you need. If you need to supplement zinc, if you need to supplement iron, if you need to supplement other elements in your diet, just a simple multivitamins, you can even find those combined pills online. So, I recommend for you to kind of to our listeners, as you think about what your body needs overall, you can make this more efficient. This way you don't spend too much money, and also you don't look at a breakfast of pills that you take every morning. So
Mhm.
but that's all good and true, and I myself even take some of these supplements all in one pill based on my dietary needs, etc. So just a little tip to be efficient. There are a lot of these on the market. Of course, make sure that you get something that's reputable, that has good quality assurance, and you can just a lot of times read some of the recommendations online and talk to your physician
Mhm.
overall to see if there's any known issues with safety. All right, but to suffice to say that these things are overall very safe. Okay, so now I want to talk to you about some of the new technologies that are emerging, and perhaps you can introduce us to some of those. I know that you had a paper recently published and some exciting news there, so maybe you can take us through some of those developments.
Right. So the technology that I've had the pleasure of being recently involved in is on something called acyclothymidine dinuclease. And so, dinucleotides. So essentially, the concept is that can you mimic, your thymine dimers, right, with a manufactured, right, thymine dimer, so to speak, so that it can receive the sunlight to act like a decoy to your own DNA. And so when it receives the sunlight, it dimerizes and then ultimately can elicit your own endogenous DNA repair response. All right, so let's let that settle in for a second here, right? We're making some DNA, we're
Yes,
manufacturing
please.
some DNA,
Yeah.
right? Right? You're making some thymines, right? But it's really hard, actually. So back in the day, actually, this work came from Barbara Gilchrist, actually, way back. And so there's a concept of making thymidine in the lab, right, and manufacturing it, and then putting it onto skin cells or inside the body to kind of to create the DNA damage repair system, right? But from her work, we found out that this is in the late 90s, early 2000s, that it is very hard to make pure thymine dimers. It's just really hard to do that chemically. Then folks over at the University of Minnesota, right, in Minneapolis, they were brilliant and they took that technology to the next level. And their medicinal chemists were able to make cyclic versions of thymines, right? And that allowed for a good manufacturing protocol. It was easier to do. You get greater stability. You can manufacture it well, and then you can put it into topicals with stability. And that was the key that was missing all along over the last 20 years. So this medicinal chemistry was unlocked, and then they proved, all right, in original studies. First, what they had done, and this was really cool, was that they put some DNA fragments into a vial, and they shone light, right, onto the vial, and saw that thymine dimers happened, right, as a proof of concept. Great, it was a great study design, right? Put DNA in a vial, put some light, boom, you get thymine dimer. But then they put this, cyclic thymidines into the vial, and they shine light again. But this time around, they didn't see the thymine dimers in the original DNA. They saw it in this manufactured thymidine, right? Which was awesome. So that was a sign that says, hey, maybe this thing can truly act like a decoy and like be the umbrella on our own DNA. And they proved exactly that. Then the next step was, can this molecule, once the light has touched it, bring forth the DNA repair enzymes? And they also proved that in human keratinocytes, right? So they dumped it in, they put some light on there, and then they were able to bring these these DNA repair enzymes to the fore, and they show that with immunohistochemistry. Great, right? So we're tracking from the vials to human skin cells, and then in mice, they did the same thing, but also they showed in one of their earlier papers was that this molecule can potentially prevent the formation of keratinocyte cancers for that reason, right? So there's some lovely data there to show that. And then ultimately, what we had done in humans is that we looked at abdominal skin explants. So basically, those patients who underwent, let's say, a tummy tuck by a plastic surgeon, we took the leftover skin, and we also did different formulations of this, acyclic thymidines, put them on there, and then shine some light on them, and we were able to show in human skin that you get the protection of your own skin cells as well as the DNA repair enzymes coming in and taking away some prior mutations as well. So that was the journey of this molecule, the development and biological basis of this molecule. And now it exists. Actually, the name of this is called protexidine, Protexidine, protexidine. And there's multiple formulations that exist that are over the counter, but they are sold slash dispensed, at clinics, right? You can't just go to the store and buy it. It has to be at the dermatology clinic or some equivalent there as well. But you have an eye cream that helps you with the periorbital area, and there's also a sunscreen that's about to launch that includes that technology. So we're waiting for that to drop. And last but not least, there's a pigment correcting cream that contains, in addition to this technology, like things like arbutin and what have you, and some peptides to be able to help reverse some of that pigmentary alteration as well.
Yeah, that's really fascinating, and this kind of body of knowledge that slowly evolved, and actually was also. I was doing some reading on this. It seems
Mm.
like the whole concept of it was to protect from, also you can protect from chemotherapy, so to protect the gut lining, for example, from
Mhm.
chemotherapy. So other ways of doing this. Really fascinating concept, and to me, always the human mind is boggles me that people thinking strategically about these problems and how to develop molecules that are specific to that is really fascinating.
Mhm.
Really super exciting because we always look to add to our toolkit when we talk about sun protection and things that folks may find more. More appealing to their way of thinking about sun protection. So it's nice to have another thing coming. That's wonderful. I wonder, and I heard you describe this sort of preclinical evidence, but we don't have any large randomized trials on this just yet, right?
Correct. So randomized trials don't exist. I also unfortunately think that they probably won't happen just because of the sheer size and resources required. But there is, proofs of concept.
Yeah, no, and a lot of times it's worth talking about safety in this context because if something is very safe, so if I told you that a cucumber can make you jump 30 feet high, you probably won't believe me, but hey, if you ate one cucumber, nothing happened. If you didn't jump, you didn't jump, right? So
Right.
there's a very, very low risk. So what are some safety considerations that could happen here?
So interestingly enough, there's actually minimal to no safety considerations. So protexidine was studied actually for initially corrosivity and irritation. So you typically do that, in animal models of dorsal skin, and you found that there was no inflammation, right? And then for mutagenicity as well. So these are standard toxicology screens that we do for any molecule that's going to get into the market, right? So you do corrosivity and irritation. You look at mutagenicity, and there was no mutagenicity or genotoxicity. So there's mutagens and genotox, and this is what can lead to cancer, right? So that's great. So they passed the test there, as well as the clinical and laboratory findings in terms of histologic changes of not just the skin, but also internal organs as well, lung, bowel, you name it, right? So there was no histologic changes over time. And this is in standard animal models. And last but not least, laboratory parameters for animals as well as human testing were all normal. And so now, granted, in theory should be safe also in pregnancy and in lactation, but just like anything else, it is very difficult to actually design a study that is ethical to do that.
Well, that was a great overview, Naeem. Thank you so much. Folks, you really got here to hear from the pro about all this. We talked about so much that involves in sun protection, not only the basics of when to go out, how to safely enjoy the sun and get some of the benefits, but also how to protect from the evils that the sun can do sometimes if we are not careful. Obviously, we talked about how to protect with sun protection and the broad spectrum approach and some tints that you can add. We talked about some oral supplements that you can ingest, and especially we talked about Polypodium leucotomus, which is available on the market. We talked about nicotinamide, and I think we mentioned, just so there's no confusion, we mentioned the flushing. Flushing can happen mostly with the other type of B3 vitamin, which is niacin. So nicotinamide usually, as was mentioned here, rarely we see in clinic any issues with that. And then we really went on to talk about some of the issues, some of the new developments, and really cool to hear about these new upcoming sun protective strategies that are, wow, completely different than what we've done so far. So protecting all the aspects, all the modules in your formula from the rays coming from the outside, reactive oxygen species, and of course, some mutations that can happen in our genome. So fascinating tour de force. Thank you, Naeem. Good luck in everything you do. Really, not so rising star anymore, just like a star right there, shining in the middle of our dermatology galaxy. Thank you so much, and hope to see you on future episodes.
It's a pleasure. Thank you so much for having me. See you soon.
And that's a wrap for today's episode. But if conversations like this get you all excited, that's exactly what the Integrative Dermatology Symposium is all about.
And I'm all excited about it. The 9th Annual Integrative Dermatology Symposium will once again bring together clinicians, researchers, and educators who are shaping the future of dermatology. And this year, there'll be a focus on precision, regeneration, and whole person skin health. It's happening from August the 20th to the 22nd at the Grand Hyatt Indian Wells in Palm Springs, California.
IDS is where evidence meets application. Through expert-led sessions, real-world case discussions, and meaningful collaboration, or in plain English, IDS is where you get to talk to a whole bunch of people who are equally skin-obsessed.
I'm also equally skin-obsessed. If you want to be a part of the largest community in integrative dermatology, use the code PODCAST15 for 15% off registration at integrativedermatologysymposium.com.
That's integrativedermatologysymposium.com. We can't wait to see you there.